exponential equations. We are going to be using this particular property to start. And it tells us if we have an equation with the same base on each side, then we can actually drop the base and set the exponents equal to one another. So if we have something of the form a to the u equals a to the b, then that means a, or we can drop that a and say that u equals v. That's the property we will be using. If I said 3 to the x plus 1 power equals 81. So we're trying to find x. If we want to use the property, then we have to have the same base on each side. Can you break down 3 at all? No. So that has to stay the same. So ideally, I need to write this 81 as 3 to some power. 3 to the 4th power is 81. So I didn't change my problem, I just wrote it in an equivalent form. Then, since I have the same base on each side, you can set the exponents equal to one another. X is 3. And you can always check on these. If you plug in your 3, you get 3 to the 4th, which is 81. It does work. That's all it is. No, why not? Thank you. All right. What option can we use here? Okay, so there's really 2 different ways to do this. If we keep it as 1/5, the question is 1/5 to what power would equal 1/25? 2. 1 squared is 1, 5 squared is 25. So x equals 2. Bless you. It's 2.
So good.
Double exponents.
Now you got me going.
Great. What would I do here? Okay, so we have 3 to the x cubed. 9 is 3 squared. Since it was 9 to the x, my 9 becomes a 3 squared, but that x is still on the outside. When you have those exponents, a power to a power, what do you do with the exponents? So that becomes 3 to the 2x power. So then we can set the exponents equal to one another. What would we do to solve this? We subtract over 2x, then we have a greatest common factor. Yeah, it's not perfect. We'll have a radical answer. So we get x equals 0 and x squared minus 2 equals 0. So x squared is 2. So x is... So this time we actually got 3 answers. Square root of 2, negative square root of 2, and 0. And you can check all of those. You just plug them back into the original.
They all work.
They should all work. As long as your math is correct, you're not going to get extra answers on these. Alright, can we try something? Let's add something to the problems. We seem pretty good with the basic ones. Need some allergy medicine. Can I multiply my 4 and 2?
No, because they're exponents.
Okay.
Oh, we do this pretty good.
I don't know.
You take out 2 squared.
Okay. So order of operations says you have to do exponents before we multiply. So we can't multiply these together. Instead, we can break them down. So I'm looking, my bases are 4, 2, and 16. All of those are powers of 2. So my 4 to the x, I can change to 2 squared to the x. We can leave the 2 to the x squared alone. 16 squared would be, whoops, not 4, 2 to the 4th squared. Exponent rules, when you have a power to a power, you multiply. Okay, we still can't use our property yet. The property only works if you only have one base on each side. So if I'm multiplying these, good luck. What do we do with their exponents? Add them. So this is 2 to the x squared plus 2x. Now we have the same base on each side, so now we can set the exponents equal to one another.
And you eat over.
So multiply the -8 and add the +2. And then we set each of those equal to 0, so we get -4 and +2 for the answers. I encourage you to check, but you're not going to get answers that don't work on these as long as your math is correct. So it's not like a requirement where we have extra answers. But on a test, I would, if it were me, I'd probably take the time to check them. Okay. Let's try a few more.
E's.
Yeah, there's an E.
Oh, are these just E's or like T's?
Does this E change anything?
No.
No, that's just my base. We work it the same way.
It's not the log. It's not the log E.
So we have e to the x squared equals e to the 3x times. Okay, I'm trying to get a base of e. How would I rewrite 1 over e squared?
Put an angle on it.
Yeah, that's e to the -2. We know negative exponents change forms. And so then if we are multiplying with those e's, we add our exponents. So now we can set the exponents equal to one another. Quadratic, so bring everything over. So subtract your 3x, add your 2.
Wait. -2 and
And set those equal to 0, so we get 1 and 2 for the answers. Alright. You guys think you can try one? You do this one. Alright, so we have to change all these. Oops, the 2, the 4, the 1 over 64. We can make all these a base of 2. So 2 is 2 to the first. 4 is 2 squared. 1 over 64. So to move it up, it would have to be a negative 6. So we have 2 to the first times 2 to the 6x equals 2 to the -6. when you're multiplying, if that base is written each time, you add the exponents. And then if we have the same base on each side, what do we do with our exponents? So we subtract over the 1, divide by 6. So we get negative 7 over 6.
I got so chaotic deja vu just then.
Alright, we're going to do a couple more and then I'm done.
What is that?
That's my sticker. Look in here. Look at that. It's a little penis cowboy hat that says be all.
I was looking at it when I walked by.
Give it back.
That's too late.
Give it. You did not stick.
It's,
Give it here.
What would my common base be? Yeah. 5. Okay, how would you write a cube root?
1/3.
Right, and over here we had a 1/5. So if I want to write that 5 to the negative 1, all we're doing is switching floors and we make it a negative. Alright, power to a power, we then we can set the exponents equal to one another. So if I'm solving for x, I can add my x over. Divide by 2/3. Or multiply by 3/2, and we get negative. So we can do it with radicals too. We just write those with the fraction exponent.
I remember in this college class, I would always try to divide by a fraction, which you would be like, no,
No.
just multiply it by 37.
And he tried it like every time, like the rules of math. He gives
Then
them.
worse, both.
It's the same thing.
And the
Yeah.
calculator works the same.
Okay. What if I gave you this?
I quit.
Oh, what?
God.
This is the same thing.
It's the exact same thing.
What's the common?
Yeah, that's the question.
5.
5.
How do you get a 5 out of a
Multiply.
1? No.
So we have
Yes.
5
by both sides.
to the 2x minus 3. You want this to be 5. So the question is 5 to what power equals 1? Anything to the 0 power is 1. Add your 3. Divide by 2. That wasn't so bad. Hmm? Yeah.
I remember when we first learned that anything with front of 0 equals 1 because that same day we had a quiz math and that was one of the questions and the other team didn't get it. It was a beautiful thing.
There is a handout posted on Classroom. It's a little bit, there's more questions than usual, but they're pretty quick. So, got the rest of the